Some of history's most powerful inventions were impossible to ignore. The steam engine transformed factories. The airplane transformed distance. The internet transformed communication. The semiconductor did something different. It transformed everything, without most people ever noticing. It does not produce headlines. It produces the technologies behind them. Every smartphone, every satellite, every data center, every autonomous machine, every artificial intelligence model, every digital payment, every modern aircraft, every scientific simulation, all begin with one invisible component, a tiny piece of silicon. History often celebrates the products people can see. Architects study the components that make those products possible, because the most important architecture is rarely the most visible. Every civilization reaches a point where its greatest limitation becomes computation, not physical strength, not natural resources, the ability to process information. Early computers occupied entire rooms. They consumed enormous amounts of electricity, performed only a fraction of the calculations today's devices complete every second. Then silicon changed the equation. Millions of transistors became billions. Billions became tens of billions. Each generation became smaller, faster, more efficient, more powerful. This silent progression reshaped the modern world. Artificial intelligence did not suddenly appear. Cloud computing did not emerge by accident. Autonomous systems did not evolve overnight. Each breakthrough stood upon decades of invisible progress inside a silicon chip. Most revolutions begin long before the world notices them, because progress usually starts where almost nobody is looking. Electricity powers machines. Silicon gives those machines intelligence. Every connected device, every sensor, every processor, every network depends upon billions of microscopic switches working together with extraordinary precision. We rarely notice them because great infrastructure disappears into everyday life. People admire the smartphone. Architects study the processor inside it. People celebrate artificial intelligence. Architects examine the chips making that intelligence possible. Visible innovation often captures public attention. Invisible infrastructure quietly determines its limits. The true engine of the digital economy is not software alone. It is the hardware capable of executing billions of decisions every second. Without that foundation, every digital ambition remains only an idea.
Modern civilization depends upon one extraordinary capability: precision. Not measured in centimeters or millimeters, but in nanometers. At this scale, engineering approaches the boundaries of physics itself. A microscopic imperfection can determine whether an entire processor succeeds or fails. Every improvement requires deeper scientific understanding, greater manufacturing discipline, and decades of accumulated knowledge. This is why semiconductor leadership cannot be built overnight. It is the result of thousands of invisible innovations layered upon one another across generations. The world often measures power by military strength, economic output, or natural resources. Increasingly, another form of power is emerging: the ability to manufacture intelligence itself. Every civilization depends upon critical infrastructure.
Sometimes that infrastructure is obvious: a bridge, a port, an electrical grid. Sometimes it is almost invisible: a tiny silicon chip. Modern civilization cannot function without it. Communication slows. Factories stop. Financial systems weaken. Artificial intelligence loses its foundation. This is why semiconductors are no longer just electronic components. They have become strategic infrastructure. Control over computation increasingly means influence over innovation. Influence over innovation shapes economic power. And economic power quietly reshapes global power. The smallest technologies often create the largest dependencies, because every intelligent system eventually converges upon the same foundation: computation. The 20th century was shaped by energy. The 21st century is increasingly shaped by computation. Oil powered machines. Silicon powers intelligence. Energy determined industrial capacity. Computation determines cognitive capacity. The world's most valuable organizations no longer compete only for physical resources. They compete for computational capability. Every additional processor expands what civilization can calculate. Every new generation of chips expands what civilization can understand. This is why semiconductor manufacturing has become more than an industry. It has become a strategic resource. Not because silicon itself is rare, but because the architecture required to transform it into intelligence is extraordinarily difficult to build. The future will not be limited by ideas. It will increasingly be limited by the ability to compute them. History remembers the races that changed civilization. The race to cross oceans, the race to reach space, the race to connect the world through the internet. Today, another race is unfolding, not for territory, not for population, but for computational capacity. Because computation determines discovery. Discovery determines innovation. Innovation determines productivity. And productivity shapes long-term prosperity. Artificial intelligence has accelerated this race. Every breakthrough demands greater computational power, greater efficiency, greater precision. The competition is no longer centered on who builds the next application. It is centered on who builds the architecture capable of supporting every application that follows. Civilizations rarely compete over today's technology. They compete over tomorrow's infrastructure. Civilizations are often remembered by what they build: pyramids, cathedrals, railways, skyscrapers. History remembers the structures. Architects study the foundations beneath them. The digital civilization follows the same principle. Artificial intelligence appears to be the revolution. Cloud computing appears to be the infrastructure. Autonomous machines appear to be the future. But beneath every breakthrough lies the same invisible foundation: silicon. Not because silicon is extraordinary by itself, but because it gives intelligence a physical form. Every calculation begins there. Every prediction begins there. Every model begins there. Before intelligence can transform the world, it must first pass through silicon.
Power has always depended upon infrastructure. Empires built roads. Industrial nations built factories. Digital civilization builds computation. The nations, organizations, and institutions shaping the future all share one common priority: expanding computational capability. Because computation accelerates research. Research accelerates innovation. Innovation accelerates productivity. And productivity compounds into long-term influence. The future will not be defined only by those who invent new technologies. It will be defined by those who possess the architecture capable of sustaining continuous innovation. Behind every intelligent system, there is computation. Behind every computation, there is silicon. And behind every generation of silicon, there is an architecture decades in the making.
Most people experience the digital world through applications. Architects see the layers beneath them. Applications depend on intelligence. Intelligence depends on computation. Computation depends on silicon. Silicon depends on decades of accumulated knowledge. The visible world is built upon invisible architecture. That pattern repeats throughout history. The strongest civilizations were never defined by what people could easily see. They were defined by the systems quietly supporting everything else. The intelligence age will follow the same principle. Artificial intelligence will continue evolving. Cloud infrastructure will continue expanding. Autonomous systems will become increasingly capable. Yet every new possibility will still depend upon one enduring foundation: the architecture that transforms matter into computation, and computation into intelligence. Because the future is not built from technology alone. It is built from the invisible architectures that allow technology to evolve.
Every generation believes it is witnessing the next great invention. History tells a different story. The inventions that reshape civilization are rarely the most visible. They are the ones that quietly become indispensable. Silicon is one of them. It does not seek attention. It enables everything that does. At Asutsen, we look beyond products and headlines. We explore the invisible architectures that determine how wealth is created, how intelligence is scaled, and how civilizations evolve. Because when you understand the foundation, you begin to understand the future. And when you understand the architecture, you stop chasing change. You begin designing it. Welcome to Asutsen, architecting wealth, automating future.